Welcome back. Before we start our deep dive into today's topic, please take a second to hit that like button, subscribe to the channel and turn on notifications so you never miss a technical breakdown. It really helps the channel grow. Welcome to this deep dive into Apache Sandesha2. In distributed systems, network failures are inevitable. Sandesha2 brings reliability to SOAP-based web services by implementing the WS-ReliableMessaging standard. It ensures that your messages are delivered in order, without duplication, and without loss, even over unreliable networks. This makes it a critical component for enterprise applications in finance, healthcare, and beyond. Before diving into Sandesha2, let's understand the foundation: WS-ReliableMessaging. This OASIS standard defines how SOAP messages can be reliably exchanged over unreliable transports like HTTP. It introduces concepts like message sequencing, acknowledgments, and retransmissions. This ensures that even if a message is lost in transit, it will be resent and processed exactly once at the destination. Sandesha2 stands out because it brings WS-ReliableMessaging to Axis2 with minimal configuration. It works transparently with your existing services, adding reliability without changing your business logic. Whether you're a client sending messages or a service receiving them, Sandesha2 handles the complexity of acknowledgments, retransmissions, and ordering behind the scenes. Sandesha2 provides a robust set of features to ensure reliable messaging. It tracks each message using unique sequence identifiers and expects acknowledgments. If a message is not acknowledged within a configured time, it's automatically retransmitted. It also prevents duplicate processing by detecting repeated messages and filtering them out. Sandesha2 is implemented as an Axis2 module, which means it hooks into Axis2's processing pipeline. It introduces new phases and handlers to manage reliable messaging. These handlers are responsible for creating message sequences, tracking acknowledgments, and managing retransmissions. It also uses storage mechanisms to persist message states, ensuring reliability even across restarts. At the heart of Sandesha2 is the concept of message sequences. Each sequence is identified by a unique ID and contains a series of numbered messages. Sandesha2 tracks the lifecycle of each sequence, from creation to termination. It supports both short-lived interactions and long-running sessions, allowing partial acknowledgments and handling message gaps gracefully. Acknowledgments are crucial to Sandesha2 reliability model. Each message sent must be acknowledged by the receiver. If an acknowledgment is not received within a configured time, Sandesha2 retransmits the message. Acknowledgements can be sent individually or batched together, and timeouts can be tuned based on network conditions or service requirements. When a message is not acknowledged, Sandesha2 initiates retransmission. It uses intelligent retry strategies, including exponential backoff, to avoid overwhelming the network. You can configure the maximum number of retries and the behavior for each sequence. Retransmission is handled entirely by Sandesha2, so your application code remains clean and focused. To ensure exactly once delivery, Sandesha2 detects and filters out duplicate messages. It tracks every message by its sequence ID and message number. If a duplicate arrives, it's silently discarded. This mechanism works even across system restarts, thanks to persistent storage layers that maintain the state of processed messages. Sandesha2 gives you control over message ordering. You can enforce strict in-order delivery for applications that depend on message sequence, or allow out-of-order delivery for better performance. This flexibility is especially useful in high-throughput systems where message ordering is not critical, but reliability is still required. To maintain reliability across system restarts, Sandesha2 supports persistent storage. By default, it can use in-memory storage for performance, but for production systems, you can configure JDBC or file-based storage. This ensures that message states are preserved even if the server goes down, allowing Sandesha2 to resume reliably when it comes back online. Security is just as important as reliability. Sandesha2 integrates with Apache Rampart, which brings WS security capabilities to Axis2. Together, they provide a complete solution for secure, reliable messaging. You can configure encryption, signing, and authentication using policy files, ensuring that your messages are both secure and delivered reliably. On the client side, enabling Sandesha2 is straightforward. You can configure reliability through Axis2 configuration files or programmatically using APIs. Sandesha2 automatically manages message sequences and acknowledgments, making it easy to send reliable messages to remote services without modifying your core business logic. On the service side, you enable Sandesha2 by activating its module in Axis. Once enabled, it processes incoming reliable message sequences, ensures ordered delivery, filters duplicates, and sends acknowledgements back to clients. This all happens transparently, so your service logic remains clean and focused. Sandesha2 is highly configurable. You can define reliability policies using WS policy format, which allows you to specify timeouts, retry limits, and delivery modes. These policies can be applied globally or on a per-service basis, giving you fine-grained control over how reliability is enforced in your system. While Sandesha2 brings reliability, it also introduces overhead. Acknowledgments, storage, and ordering all add latency. To optimize performance, you can use in-memory storage, allow unordered delivery, and tune timeouts and retries. Synchronous processing also helps scale your system under load. Debugging reliable messaging can be complex, but Sandesha2 provides detailed logging and monitoring capabilities. You can track sequence states, message IDs, and errors through logs. It also supports JMX for real-time monitoring, making it easier to diagnose issues like timeouts or delivery failures in production. Let's look at a real-world example: financial messaging. In payment systems, every transaction must be reliably delivered. Sandesha2 ensures that payment instructions are not lost or duplicated. Combined with Rampart for encryption, it provides a secure and compliant solution for financial institutions. In healthcare, patient data must be exchanged reliably and securely. Sandesha2 ensures that records are delivered exactly once and in order. When combined with Rampart, it meets HIPAA compliance by encrypting data in transit, making it ideal for healthcare interoperability systems. How does Sandesha2 compare to other messaging solutions? Unlike JMS, which uses message queues, Sandesha2 works over HTTP and integrates with SOAP. Compared to REST, it adds reliability. While newer tools like Kafka or RabbitMQ are popular for async messaging, Sandesha2 remains a strong choice for enterprise SOAP-based systems. Getting started with Sandesha2 is straightforward. Download the binaries, deploy them into your Axis2 modules directory, and enable the module in your configuration files. You can then define reliability policies and test with sample clients and services to ensure everything is working as expected. Here's a quick look at client-side code. You enable reliability by setting options on the service client. You can configure timeouts, retries, and other reliability settings. The rest is handled automatically by Sandesha2, making it easy to send reliable messages with minimal code changes. On the service side, you enable Sandesha2 in your services, XML file, and define reliability policies. Your service logic remains unchanged. Sandesha2 handles acknowledgments and ordering behind the scenes. You can log message states for better monitoring and debugging. When troubleshooting Sandesha2, start by checking logs for sequence or acknowledgement errors. Ensure the module is enabled and that policies match on both ends. Adjust timeouts and retries based on your network. Monitoring tools can help trace message flows and identify bottlenecks. To get the most out of Sandesha2, use persistent storage in production, tune timeouts based on your SLAs, and monitor sequences and acknowledgements. Log errors for debugging and audits, and always combine Sandesha2 with Rampart for secure, reliable messaging. While powerful, Sandesha2 has its limitations. It adds latency due to acknowledgments and retransmissions. It also requires deep Axis2 knowledge for customization. Documentation is limited, and it's not ideal for ultra-low latency systems. Always persist sequence states for true reliability. For help with Sandesha2, check out the official Apache project page, Axis2 mailing lists, and sample projects on GitHub. Stack Overflow is great for troubleshooting, and enterprise support is available from consulting firms specializing in Axis2 and Sandesha2. While Sandesha2 is not actively developed, it remains relevant in legacy enterprise systems. The shift to REST and microservices has reduced its usage, but for SOAP-based systems requiring reliability, Sandesha2 is still a solid choice. Community-driven updates keep it alive for those who need it. Sandesha2 is not ideal for lightweight microservices due to its Axis2 dependency and overhead. It's better suited for traditional SOA systems. For critical inter-service communication, modern tools like Kafka or gRPC are preferred, offering better performance and simpler deployment. To summarize, Sandesha2 is a powerful tool for adding reliability to SOAP-based web services. It ensures messages are delivered reliably in order and without duplication. Combined with Rampart, it offers both reliability and security. While it requires tuning and monitoring, it's a solid choice for enterprise systems with strict reliability requirements. If you found this tutorial helpful, smash that like button and subscribe for more enterprise-grade tutorials. Drop a comment below with your use cases or questions, and don't forget to share this video with your colleagues working on Axis2 or SOAP-based systems. And that wraps up our explanation. If you found this useful, please hit the like button and share it with a fellow developer. Don't forget to subscribe for more technical tutorials. Thanks for watching, and I'll see you in the next one.